example 1, I can divide by 3 equation 1, so I get 3 times x plus 2 times y equals 10. And equation 2 is going to be divided by 2, so I finally get 3 times x minus 2 times y equals 2. Finally, I can add these two equations, so I eliminate y. 6 times x equals 12, x equals 2. Since I get the value of x, I can find the value of y by replacing 2 into any of both equations. 12 minus 4 times y equals 4. Finally, y equals 2 as well. In example 2, I can sum equation 1 and equation 2, so I eliminate y and I get x plus z equals 30. Then I can isolate x. X equals 30 minus z, and I can replace this one into this third equation. 30 minus z minus 2 times z equals 60. Finally, z equals minus 10. Since I get z, I can find x and I can find y. X equals 40 and y equals minus 15. An equation states that two algebraic expressions are equal. Its solution is the value of all stated variables that make the statement true. Do not forget that the number of unknown values must be equal to the number of equations given. Otherwise, the system of equations can be solved. Two common methods are used to solve these equations simultaneously: substitution and elimination. Substitution. One variable is isolated in any of both equations and substitute it into the second equation to transform it into a linear equation. For instance, x equals 7 minus y. Therefore, 5 times 7 minus y minus 2 times y equals 21. We can solve for y. Finally, y equals 2. Once we get the value of y, we can find the value of x, which is 5. Elimination. Two equations can be added together to create a third equation and thus eliminate one variable. For instance, I can multiply equation 1 by 2, so I get 2 times x plus 2 times y equals 14. Now I'm gonna add equation 2 to equation 1 in order to eliminate y. 7 times x equals 35. Finally, x equals 5. Since I get the value of x, I can find the value of y by replacing 5 into any of both equations. Y equals 2. Quadratic equations have an x-squared term, which means they are second-degree equations. Its standard form is a times x squared plus b times x plus c equals to 0, where a, b, and c are all real numbers and a cannot be 0. The general formula for solving a quadratic equation is minus b plus or minus the square root of b squared minus 4 times a times c over 2 times a. We're not going to use this formula in order to find the solutions or roots of the equation, but we're going to use the discriminant, that is this expression inside square root. The discriminant d equals b squared minus 4 times a times c. And if the discriminant is a positive number, it means that the quadratic equation has two different solutions or two different roots. If the discriminant is equal to 0, then it means that the equation has only one root or one solution. And finally, if the discriminant is a negative number, it means that the equation has no solutions or no roots. Now, in the example on the right side, what is the greatest integer value that c can take if x squared minus c times x plus c equals 0? Has two different roots. So, we want that this equation has two roots. So, it means that the discriminant is going to be a positive number, and the discriminant for this equation is b squared, this one is b, minus, here a is 1, 4 times a times c, and this must be greater than 0. So we got 36 minus 4 times c is greater than 0. 36 is greater than 4 times c. Finally, c is less than 9. Let's go back to the question. What is the greatest integer value x? What is the greatest integer value that c can take if the equation has two different roots? So, c is a number that is less than 9, and c is an integer. So, what is the greatest integer value less than 9? Of course, x must be 8. 8 is the greatest integer less than 9. So, if c is 8, then this equation is going to have two different roots. To find the solutions of roots, we need to set one side to 0. Here we have the equation set to 0, and here we have the equation set to 0 as well. That's good. After that, we need to find two numbers that add to b, or b is minus 7, and multiply to c, or c is minus 2. So, two numbers that multiply c are minus 2 and positive 1. Two numbers that multiply 15 times x squared are 3 times x and 5 times x. Finally, cross multiply 3 times x and minus 10 times 7. These two numbers, the sum of these two numbers is b minus 7 times x. So we have found the correct factors. So finally we get that 3 times x minus 2 times 5 times x plus 1 equals 0. This product equals this expression above. So we need to set each factor equal to 0, such as 3 times x minus 2 equals to 0, and 5 times x plus 1 equals to 0. So 3 times x equals 2, x equals 2/3, and 5 times x equals minus 1. Finally, x equals negative 1/5. And the following example, we have positive 3 and positive 2 are 6. 2 times 3, 6. Then we have x and x. X times x, x squared. cross multiply. 2 times x and 3 times x. The sum of these two numbers equals b, 5 times x. So finally x plus 3 times x plus 2 equals 0. This product is the same as this equation. So we need to set each factor to 0 in order to find the values of x. X plus 3 equals to 0 and x plus 2 equals to 0. Finally x is minus 3 or x is minus 2. In order to find the roots, we need to follow the steps taught in the last slide. We need to set the equation to 0 and find two numbers that add to minus 9 and multiply 20 or positive 20. I think they are minus 4 and minus 5, because if I do cross multiply and add the products, I get minus 9. So it means that x minus 4 times x minus 5 equals 0. Therefore x must be 4 or 5. Here I can divide all the equation by 15. So I get x power to 2 minus 4 times x minus 12 equals 0. And then I need to find two numbers that add to minus 4 and multiply minus 12. And I think they are minus 6 and positive 2, because if I do cross multiply and add products, I get minus 4. It means that x minus 6 times x plus 2 equals 0, and x must be 6 or minus 2. The square root of a number is always positive, therefore x equals 4. Here, this is a quadratic equation, therefore x has two roots, positive 4 and minus 4. And here, this is a cubic equation, therefore x has 3 roots. First we need to factorize this expression. Finally, we get that x equals 0, x equals 4, and x equals minus 4.